In this video, we're going to talk about another business application that deals with binary optimization. We're going to see how we can optimize product design in order to find the maximum market share. So product design and market share optimization is the problem that we're going to talk about. But before that, we need to understand one concept, which is conjoint analysis. Conjoint analysis is a market research technique, is actually a statistical technique that mainly uses regression analysis, multiple regression analysis, in order to find the part worth of people. And by part worth, I mean the weight that people put on different level of different attributes of a product. Just to make it a little more clear here, I have one very simple example. Right, like I said, conjoint analysis is a statistical procedure for finding the part worth of different levels of a feature of a product for every single person, every person that evaluates product, right? And it only uses linear regression, multiple linear regression. So I'm just gonna clarify this using one simple example. Assume um, for a company, we have only one product, mug, simple mug, and they want to see how people are perceiving different attributes and different levels of uh, different attributes of the product. So for this product, we're considering only two attributes, size and color, right? Size of marks and color of marks, and assume, so these are called attributes or characteristics of the product. And then each attribute, each characteristics can take on two different values or two different levels. Size can be either large or small in our example. Color can take on, again, two different levels. It can be red or blue. So two features or two attributes with each one two different levels. So two by two, four different possible scenarios, four different types of mugs can be produced. A large mug with red color, a blue color large mug, small red color mug, small blue color mug. Four different types of mugs, right? Mug one, two, three, and four. So these are all the possible combinations of all these attributes for this specific type of product, right? In order to be able to optimize your product design, so because the product design is basically picking levels out of different attributes, right? So you want to pick, for let's say size, you want to pick one of these two, and it can be only one of these two. And same thing for color, you want to pick one of these colors, and then your product design will be one of these four, right? Out of all these possible scenarios, you're going to pick one. But this one, you want it to be the one that gives you the maximum market share. It's you want to come up with one design that is more preferable, but by most people in the market, right? Conjoint analysis, what it does, it actually asks people to rank different scenarios, different combination of products. In this case, all these four types of mugs that we have. It asks people to give scores, let's say from 0 to 10. And let's say for a customer, we have these hypothetical scores. Let's say customer number one gave scores of 5, 3, 10, and 8 to all these different mugs respectively, right? So 5 to Mark 1, 3 to Mark 2, 10 to Mark 3, 8 to Mark 4. So customer one definitely sees all these sizes and all these colors, but customer one is not putting explicitly, doesn't put weights on different levels. Customer one puts weights and scores on different products, which is a combination of all these levels. But what conjoint analysis does is actually breaks down all these points into different part worth. Now that's what we call it. Part worth is the utility that the person, that the customer receives by getting that specific level of that attribute. All right, so what conjoint analysis does for this customer using linear regression technique, it just breaks it down, all these points, into uh, part worth, scores that the person implicitly put on different levels of different attributes. So we have, like I said, two attributes, each one two levels. So in total, four levels of different attributes. If you just break down these, if you analyze these points, you will get to these part worth. So the most important level for this customer is going to be size S. And this customer appreciates small size the most. The least important level from this, from the perspective of this customer, would be the blue color that actually has a part worth of 1. And the assumption with part worth is that the utility that you can add these part worths. So the utility that the customer gets from mog 1, and mog 1 is a large size with red color, large size with red color. So you can just add these two numbers and get the utility score of the person. So 2 plus 3, right? It's 5. The score that the person puts, or the utility that the person gets by consuming or by using a product that contains large size and um, red color, right? Contains these two levels for those two attributes. I mean, this is the largest one, the largest score, the largest utility that this person gets, Mark 3, small size and red color. So small size, 7 plus red color, 3. 7 plus 3, 10 is the maximum utility that this person can get. So we see that how this person is appreciating these uh, levels, and we just call those part worth. So the person, the actual customer, doesn't know. If you ask the person uh, how much you like color red compared to blue color, the person may or may not be able to identify those scores. But this is the easiest way. This is actually is a robust way and a reliable way that you can come up with the actual weights that people put on different levels of different attributes, right? So this is what conjoint analysis does. It just translates all these scores that people put on different combination of levels into part worth, which is the actual pure utility that the person gets from each individual level of each attribute. So that's just the definition of conjoint analysis. And that's just the part definition of part worth, the utility value that a customer attaches to each level of each attribute. And now you have an understanding of what we mean by each attribute and each level. Attributes are those characteristics of a product, basically the design features, and level are those are different values that each level or each attribute or each feature can take, right? We have one example here that we're gonna work on. Salem Foods, they want to offer a frozen pizza to the market, right? A frozen pizza, a type of pizza that they want to offer it to the market. Right now, there are two competitors in the market, two existing brand, Antonio's and King's, that they have the major share of the market. So if they want to be in the market and if they want to attract someone to buy their design, to buy their product, they have to compete with these two. So for a specific customer, they want to make sure that the utility that person gets by consuming their product is more than the utility that person gets by using by consuming either of the competitors product, right? So you want to be better than both of these two from a customer's perspective in order for the customer to be attracted in you and your product, right? So right now they are for a pizza, this is how they define a pizza. They define a product, a pizza, by four attributes. So the four attributes are as follows: crust, crust of the pizza, cheese, type of cheese, and type of sauce, and sausage flavor. So these are four different factors or four different attributes that can play with in terms of their product design. But then, what are their options in terms of each um, attribute? So let's just take a look at those factors. So for crust, there are two options: thin and thick. For cheese, mozzarella and blend. For sauce, smooth and chunky. For sausage flavor, mild, medium, and hot. 2 by 2 by 2 by 3. All right. So it can be how many different types of pizzas out of all these levels? 2 by 2 by 2, 8, right? By 3, 24 different types of product. So each person, conjoint analysis, if you want to do, we're not going to actually do conjoint analysis, but each person is going to report their score, the utility that they get on each one of these 24 different types of pizza. And then through conjoint analysis, through linear regression, we're going to get the part worth of each person on each level. Let's say chunky sauce, smooth sauce, and so on and so forth on all these 6 plus 3, 9 different levels. All right. So that's what we are going to skip. But it's very important to know where we get all those part worth. And it's through conjoint analysis. All right. So regression analysis is going to be used. Now, assume that we have done that. We have done the conjoint analysis for 8 people, 8 customers. We know exactly how they appreciate different levels of different attributes, right? So we have 9 different levels. I said 24 different types are possible to be made out of these levels and out of these 4 attributes and 9 different levels that we just defined. But for each customer, after running the conjoint analysis, we are going to get one part worth on each one of these levels. So 9 different numbers for each customer. All right. And this is going to be given to us. Now, we want to use this in order to be able to find the best design of pizza, the best design of the pizza that maximizes the number of people out of these 8. I mean, so far our population has 8 people in it, 8 consumers. We want to attract the maximum number of people out of these 8 people to buy our product rather than King's and Antonio's pizza type, right? So now, what are the decision variables? What is it that we need to make a decision about? So the question here is formulate and solve an integer programming problem that can help Salem come up with such a design. So design of the product is our first decision. That's what we want to do. We want to come up with the best decision. So, and this is actually, this has design. We want to pick different attributes. So it has a binary nature in it. We can say yes or no to different attributes, to not attributes. Attributes should be there always, but to different levels of each attribute. So that has a binary nature by definition, right? So that's definitely one thing. The second thing, the second set of decision variables that we need in order to be able to define our objective function. So let me go back here. So we're going to define one binary decision variable on each one of these levels: thin, thick, one variable for this, one binary variable, yes or no, yes or no, yes or no, yes or no, 9 of them. So 9 decision variables, binary decision variables, one for each level. The second set of decision variables that we have to define is going to be whether or not each customer is going to buy our product. Whether a customer is going to buy our product, whether each consumer is going to prefer our product compared to the competitor's products, right? So, and that, so we have two sets of decision variables. I'm going to go to the next slide. If Salem chooses level I for attribute J and IJs, and like I said, we have 9 attributes, 9 levels, right? Here we have 9 of them, so 9 decision variables here. There, it's going to be 1 if Salem chooses to have it, otherwise 0. And then another binary variable, which is going to be 1 if a consumer selects our product, chooses our product, chooses Salem product, it's not our product, and 0 if not, right? So now, what is the objective function? The way we just, the way the problem is stated here, it says we wanted to actually, our main problem was product design and market share optimization, right? So we want to maximize the market share. Out of these 8 people, we want to maximize the number of people that are going to buy our product, right? So maximization of all these YIs is going to give us the maximum number of people out of these 8 people that are going to come and buy our product. But we have to define, we have to make connection here, connecting YIs or YKs in this case and LIJs. We have to make this connection. First of all, let me explain this. You won't be able to have a pizza that has both mozzarella cheese and plain cheese. I mean, by definition here, you want to pick only one level for each attribute. So you can't have both smooth and chunky sauce, but you have to definitely have one of them. So out of thin and thick crust, you're going to pick one. So L1 plus L1 2 crust and thick is going to be 1. L2 1 plus L2 2 is going to be 1. L3 1 plus L3 2 is going to be 1. L4 1 plus L4 2 plus L4 3 is going to be 1. Or actually, I used attributes first and level second, but here we have level I for attribute J. So, but that's the same thing, right? So exactly one level from each attribute. That's what we have. Second, this here, we want to have we want to have the utility that the person gets, each person. This is the utility that person one gets. 11 is the utility that, let me just come here, 11 times, the person one gets this 11 utility part worth of 11 only if L11 is chosen. It's actually part of our product design. So when you multiply that by L11, that will be the actual utility that the person gets. So if that is there, 11 will be added to the utility. If L11 is 0, that will go away. It won't be considered as the utility that person 1 gets, customer 1. 11 L11 plus 2 L1 L21 plus 6 L12 plus 7 L22 and so on, plus 8 L3 4. That's the utility that the person L34, that the whole thing, the whole left-hand side is the utility that person 1 or consumer 1 gets. And we compare this with the maximum utility that this person can get if he or she uses, if he or she actually consumes King's or Antonio's product. 52 is the utility that this person can get, the maximum utility that this person can get by consuming competitors' product. All right. I'm going to show you. Here we have it, actually. Let me just come here. Current favorite. So for Antonio's brand, this is the specification of an Antonio's brand pizza right now in the market. So thick crust, mozzarella cheese, chunky sauce, medium flavored sausage. For consumer 1, if you add the part width of these levels, you're gonna get 52. And for the King's brand has thin crust, cheese, the blend cheese, right? Smooth sauce and mild flavor sausage. And then if you add the part worth of consumer 1 for these levels, you're going to get 47. So consumer 1 is going to get 50 units of utility by using Antonio's brand pizza, 47 by using King's brand pizza. So which one the consumer first consumer is going to pick? Definitely Antonio's brand pizza, right? Because it gives him or her the a higher utility. And if we want to defeat these two competitors, if we want to attract this person to buy our product, we have to compete with 52, right? Which is the utility that this person gets. So 52 times Y1. So now, in order for this person to be attracted to us, the left-hand side should be strictly greater than 52 times Y1. All right? Now, because we have to have equality in our sign, we can't have strictly greater than sign. In our solver, we have to go with equal or greater than or equal to, right? Because of that, we have to add epsilon, a very small number here to the right hand side, right? A very small number. If you add the right hand side by a very small number, you can then have greater than or equal. For that epsilon number or a small number, it's okay. Since all these coefficients are greater than 1, strictly greater than 1, it's okay. It's enough to put 1 here. 1 or a very small number, you can put 0.0001, and that's still correct. Your formulation is still correct, as long as it's a very small number, right? So see what happens. If Y1, if the utility that this person gets after you have a product design and after you have all these LIJs, if the utility that the first person gets is less than 52. If this is less than 52, this has to be 0, right? So just instead of the left-hand side for the first constraint, just put 30 and see what happens. 30, if this is less than 52, this y1 is forced to take 0, because for y1 to be 1, the left-hand side has to be greater than 50, greater than or equal to 53, or greater than 52, right? So this constraint actually logically connects y1 with all these, with actually the product design. So if our current product design is somehow not attractive enough, and the utility that the person gets at the left-hand side is less than 52, it's going to force y1 to be 0, meaning that the first person is not going to be interested in our product. If this is greater than 52, the left-hand side, if it happens to be greater than 52, then the first person is going to be strictly greater than 52, then the person is going to be interested in our product, and he or she is going to choose to buy our product rather than buying from our competitors, right? Same logic applies to other consumers. So if you just keep doing it for all 8 customers, you will get the formulation. You will get the set of constraints for connecting YKs and LIJs. And that actually wraps up our formulation. So I'm now going to go ahead and go to Excel and go to the model sheet and try to solve it. But first, I'm going to so in the model sheet, I have all these part words for different consumers, for all these 8 consumers as part of my parameters. And also I have the current favorite, which is the maximum utility that each consumer can get from the competitors. I have it here, which should be the one that we have to beat in order to be able to attract a consumer to buy our product. So the decision variables, we have 9 decision variables that define the design of our pizza, the best design of our pizza. And also we have 8 decision variables that define the whether the person is going to be captured, whether the person is going to be attracted to our product. So that is also going to be a decision variable here. All right. So what we want to maximize in this case is the sum of decision variables, sum of yi's in the formulation, right? We want to come up with the maximum number of people that are going to be attracted to our product. So that's the maximum share that we want to this is the share that we want to maximize, right? The number of people that are going to buy our product. And then in terms of the constraints, for connection constraints, we have some product of the decision variables with respect to the product design and the part worth, which is going to give us part worth of the first consumer, which is going to give us actually the total utility that consumer 1 gets by using our product, right? This has to be greater than or equal to, I said 1 plus the utility that this person gets times the utility that this person has right now at the market by using a competitor's product times y1. Or I can just bring um, this one, the current utility of this person, multiplied by y1 to the left-hand side, right? So that's basically the same thing that we see here. The actual, the utility of the person minus the utility of the person, the current utility of the person by using the competitor's product times if the person is captured, that has to be greater than or equal to a epsilon, a very small number, which we have 1 here in the formulation. And that's okay, since all these coefficients are large. But if these coefficients were small, it was better to put a very, very small number. But the 1 is enough right now. All right. So we just keep doing it for all these 8. Again, same thing for customer 8. The utility that this person gets by using our product minus the utility that the person has right now in the market by using competitor's product times whether the person is going to be captured or not. This has to be greater than or equal to a small, very small number. All right. So that's one set of constraints. The second set is whether we have to make sure that we're not picking more than or less than 1. It has to be exactly 1. So for cross, we should pick exactly 1 out of thin or thick. It has to be one of them, right? Not less than that, not more than that. Same thing for cheese, same thing for sauce, same thing for sausage flavor. Let's see. Yes. So mild, medium, hot. You have to pick exactly one of these 3 in your product design. And now our spreadsheet model is ready, is complete. We can go ahead and try to solve it by calling Excel solver and by putting all these, by setting up the solver. So we want to maximize the number of people that are interested in our product or the market share by changing the decision variables. So that's the first set. The second set is going to be, so LIJs and YIs or YKs, right? So the decision variables with respect to the product design and decision variables with respect to consumers, whether they're going to be attracted to our product or not. And then in terms of the constraints, we have the LHS left-hand side greater than or equal to 1. I can just type 1. Or I can just refer it to all these ones. And we have to have the next one only exactly and only one feature out of one level out of each attribute has to be selected. And also the binary constraints, the decision variables, all of them should be binary. So, and then solving method, simplex LP, and I think we're all set. Decision variables, binary, greater than or equal to epsilon, and equal to 1, the level of, so only 1 is selected here, 1 level out of each attribute. So if we just solve it, Excel found a feasible optimal solution. Let's take a look. So we see we exactly picked one level out of each feature, out of each attribute. And we can see that 4 people are going to be attracted to our product by relatively high margin. So consumer 1 is getting 9 utility units of utility if he or she uses, if he or she consumes our pizza rather than the competitor's pizza. 10 is great, 3 and 1. So that is I mean, the consumer 7 is not, the difference is not huge. It's just 1 unit additional utility that he or she gets by using our product. And then this is the optimal design. Thin crust, blend cheese, chunky sauce, and mild flavored sausage.